Compared to 313, fairly straightforward. There's a couple of weird things happening, and we really want to talk about rotation. So we did spend some more time kind of going in lesson 3 to talk about the different things that happen when we reflect. And specifically, we had the letter M and the letter T that we ended up drawing and found out that there was symmetry, and that's why it landed on itself. If you remember, I believe that was 312. I could be mistaken about the lesson number. So we're going to do this focusing on rotation. So I'm not going to do all of these for you. I think you can handle it. I will get us started with A here. I'm going to trace my shape onto my patty. It's going to remind us what to do. And I have my plus sign here. And I can use this picture for all of these first two. I'll be able to use the same picture for the next three, which will be nice. And it wants me to go 180 this direction. So there's 90. And this is 180. Then I'm going to trace the picture onto the paper. So we know that that's right there. We have a point right here. Straight down, open, down there. Okay, so there's my new points. And it looks like that. So then you do the same thing, but go the other direction. I'll let you do that one. And I'll come back with the answer up later, but that's what you're going to do. Then it has us doing 90, 90, and 270. So just want to kind of think of that. 90 is, so when we do the plus sign on our paper, which I'll do, and I like to put a plus sign through my dot or fold patty paper there. Plus sign's kind of nice, but the folds are great because then they take the whole patty paper over 90 this direction. So this is a 90-degree turn, right? We kind of know that already. And so that's one turn. Two turns, 90 plus 90 is 180. Three turns, 90 plus 90 plus 90 is 270. And four turns is 360. So I want you to go ahead and try all of these. Pause the video, try them all, and then see if the answers will be here shortly. All right, here we go. So we have 180, either direction, it's exactly the same. 90, we get that. 90 clockwise, we get that. Counterclockwise, we get this. 270 clockwise, we get the same. Oh, I did that backwards. I'll fix that. These are opposite directions. See what happens? And then 360 we land back. Okay, so they look like that. So then let's look at the questions we're supposed to be thinking about. Does it make any difference if a rotation is clockwise versus counterclockwise? And that would be sometimes. And so it would be any angle less than 180 and between 180 and 360. So sometimes it doesn't matter, 180 and 360. But see, are there any situations exactly on the original? That's 360. So everything but 180 and 360, it matters your direction. 180 and 360, it does not. Now let's do these two, because they are different. We have a letter N, and then rotating right around the inside of this letter N. Wants me to go 180, and it didn't give me a direction because we've kind of established that direction doesn't matter. So if you already did this one, good for you. There's 90, and here's 180. Isn't that weird? Now, if I had written something on this paper before I started, so let me just make sure we all understand that I did move it. It's kind of weird, 180. There's 180, it sits upside down, but the letter N isn't. So this one does land on itself. That is unusual for 180, as we can tell, since it didn't happen up here. And then this one did not give me a direction. Just said to go 90, which is very unusual. There's 90. And it's landed on itself if I went the other way. So these two both landed on, even though I went a number less than 360. So G and H have what we call rotational symmetry, because we were able to rotate less than 360 degrees, and still land on ourselves. And that's what rotational symmetry means. That's its definition, is that I can turn it less than 360 degrees and still land on itself. Notice it happen with any of these. And it does have to be in the center, but it wouldn't happen. Let's see that being said. So this rotation's on a grid. Now we're moving to something. Okay. Find the diagram on the left, which shows PQR reflected across line L, form P prime, Q prime, R prime. Draw 3 dashed line segments using a ruler. Now I'm not going to use a ruler. I'm going to use this lovely notepad. I'm going to go get one. I'm going to connect R to R prime, like that. And then Q to Q prime, like that. And then P to P prime. And so if you don't have a ruler handy, use your ID, your school ID. It's a great one to use, or something like Intuit. Okay, so here we are. So we draw. Oh, and I was supposed to make them dashed. Okay, dash them. I'm so great. Okay. What is the relationship between the 3 dashed segments? And if you'll notice, my slope here is down 1 over 2 because it says use your knowledge of slope. Down 1 over 2, down 1 over 2. And P is hard to tell, but it is, they all have the same slope. And based on what we talked about in the last video, that means they're parallel lines. Okay. Now focus only on segment RR prime. So just looking at this, what is the relationship between this line and this line? Okay. So line L, I use a cursive L. I'm talking about so it doesn't look like a number. And R prime So the slope of RR prime is 1 over 2, and it's negative. The slope of line L is 2 over 1, and it's positive. And so you can notice these two slopes, they've been flipped over, and the sign's been changed. And so these are perpendicular. If you prefer that right angle. They form a right angle and intersect at 90. So that's cool. So it's here, slope, I already did that, 2 over 1, negative 1 over 2. Okay, and so we slope to confirm. One other way we can confirm it is if we take those two numbers and multiply them together, we get negative 1, which is true of every perpendicular pair of slopes. So that's the confirm. Place a point at N, the intersection of R prime and the line of reflection. N. Sorry, my light went off. This is point N. What do you notice about the line segments? Use patty paper to measure. So I'm going to draw this line segment N only. There it is. And oh, they're the same. Okay. Is what we observe for this true about the others? That is it always perpendicular? So is line Q prime perpendicular to this line? Well, it has the same slope. We already said that they were parallel. So yeah, they're perpendicular. Yes. This is the midpoint because the line segments are the same. So it ends at the midpoint, and that's also true here. What's interesting? That's not always true about so yes, because if I transform one line up, it's going to maintain. It has to. That's the rule. When we talk about the definition, this is how it's going to work out. And so if I do a reflection and connect, especially slanted lines, this is so important. You connect the original image, the pre-image to the image. It will always be perpendicular to the line of reflection, which is why we have to be able to reflect across the line. We never reflect across anything but a line. Reflection will always be perpendicular and equal distance. Same distance on both sides. We've talked about that quite a bit as we've been doing them. That's how you can kind of do it without the paper. That is why. It's always true with slanted lines. It's really important. It's why P and P prime are so in the middle of nowhere, because it has to maintain that relationship, period. All right, let's take a look at our last section. If you haven't written all this down or need me to repeat myself somehow, and we need some better. All right, finish off. Definition of translation. Describe the translation, that is how much move. And so this is the original. This is the original. We've got A, B, C, and then we've got primes over here. I've marked C prime. So you can use C prime to help me. Go ahead and do that. This is 3. And that looks like 7. 7. So how much did we move? We moved 7 units to the right. And 3 units down. That's clearly true of this one. Is it true of the other? So A, 3 units and 7. And B, 3 units. And 7. Yep, through there. Okay. All right. Now we're going to plot another triangle. E, F, G with these coordinates. I'm going to use black to plot that. So E is 4, 2. F is 1, 7. And G is 2, 0. And then we're going to translate the same way it was translated up here. So that means I'm going to go down 3 units and 7 units right, which I might run out of paper. We're back. Starting with F, down 3 units, 7 units right. There's my new F. Down 3 units, 7 units right, which would be 11, just off the paper, because that's only 6 to 10. There's E prime. And then down 3 units, 7 units right. That's not 7. 7 units right. There's G. There's my new shape. Notice that they aren't the same triangle. I did my best with E. But E prime is new coordinates F prime and G prime. New coordinates of F are 8, 4. The new coordinates of, oh wait, I did that wrong. Sorry. F 8, 4. E is 11, -1, and G is 9, -. So we're drawing line segments that connect the vertex to its translated image. Blue. What I like about what happens is what it looks like when I'm done. This looks like a 3-dimensional shape, which I always think is cool. The 3 blue lines, they're all parallel. Okay, since they're all parallel, this shape that I drew first and the new pink shape, they have to be the same. Also, there's this really cool thing. You can check your points by taking, since we went 7 units right, that's +7 on the X part, and 3 units down is -3. So if I take the points and I add 7 to 4, I get 11. If I take 3 away from 2, I get -1. Add 7 to 1, I get 8. 7 take away 3 is 4. 2 and 7 make 9. 0 minus 3 is -3. That's how it works all the time. Use tracing paper to explain how you know the translation does not change any figures. We know that these are rigid motions. That's one word we used in this. Rigid transformations. Which makes the shapes exactly the same. I hope you've enjoyed this video. We will see you later.